Weird Z-shaped faults could trigger a large earthquake in California's San Andreas Fault. We're going to see the USGS Trembler map showing us the high pressure intensity of areas that will give large earthquakes. They're red over here. San Andreas Fault and the remainder on the east side of the Garlic Fault. San Andreas Fault, as we know, takes 75% of the subduction pressure of the Pacific Plate under the North American Plate. And the Walker Lane Fault System, which is right at that intersection of San Andreas with Garlic, the Walker Lane Fault System takes up the other 25%. That's where we have all the high threat volcanoes of California. And the Garlic Fault is the second largest fault of California. And that's where we had the 7.7 earthquake a few years ago. And you'll see the red sections here. Those are the ones that are prepped for a large quake. And of course, these are the weird Z-shaped faults. Now, two big earthquakes at Ridgecrest in 2019 increased the chance of San Andreas Fault quake. It's impossible to know when the San Andreas Fault will erupt with its next big one earthquake, a trembler that could impact nearly 13 million people who live in the Los Angeles metro area. It appears that two other nearby faults may have some say in the matter. The San Andreas Fault is part of the giant Z of faults. The top of the Z consists of the Ridgecrest Fault, which is, as we know, a volcanic field, the causal volcanic field. So the Ridgecrest Fault, the middle is the Garlic Fault, and the bottom is the southern part of the famous San Andreas. If the top of the Z Ridgecrest Fault were to have a really big earthquake, at least a magnitude 7.5, that could trigger an earthquake in the middle of the Z Garlic Fault, which in turn could cause a massive earthquake along the bottom of the Z San Andreas, a new study finds. These successive earthquakes would not necessarily happen all at once, but over a period of time, perhaps even decades, as stress builds up and gets transferred from one fault to the other, said study co-author Ross Stein, geophysicist and founder of the CEO of Trembler Inc., a company that models and assesses earthquake risks. He said, what we're describing is not likely, and it's a kind of an earthquake chain reaction. He said, but what we've learned about the last 4 months is chain reactions really do happen in nature. And if we're unprepared, then enormous consequences will take place. There are so many faults and earthquakes in California because that's where the Pacific Plate grinds against the North American tectonic plate. However, the San Andreas Fault, which snakes roughly 800 miles from the Salton Sea to the Mendocino coast, is notorious because it causes the deadliest earthquakes in the nation's history. The 1906 magnitude 7.8 San Francisco earthquake had 3,000 victims estimated. The new analysis of this possible earthquake chain reaction, quote unquote, earthquake chain reaction, suggests that another large San Andreas rumbler near Los Angeles is now 3.5 to 5 times more likely than scientists previously thought, thanks to the Ridgecrest earthquakes. The Garlic Fault is relatively quiet. Well, no, it's actually since that time it's had daily quakes all over the Garlic Fault, especially along the Walker Lane Fault System. Now, the Garlic Fault is relatively quiet. It has not released a significant earthquake in about 500 years, but if the Garlic Fault ruptures with about 30 miles of its junction with San Andreas Fault, it could raise the likelihood of a San Andreas quake to the southeast, the so-called Mojave section, by a factor of about 150, Stein said, and also study co-author Sinja Toda, a professor of natural disaster research who specializes in seismology at Tohoku University in Japan. And they wrote, we thus estimate the net chance of a large San Andreas earthquake in the next 12 months to be 1.15%, or one chance in 87. Now, such an earthquake could be catastrophic. Were a magnitude 7.8 earthquake to hit the southern San Andreas Fault, it could cause more than 1,800 victims, 50,000 injuries, and $200 billion in damage and other losses, according to a 2008 report from the U.S. Geological Survey. Triggered by earthquake? It was the 2019 Ridgecrest earthquakes that led to this investigation, Stein said. Ridgecrest has had 4 big earthquakes and many smaller ones over the past years, and magnitude 6.4, and then the magnitude 7.1 July 2019, the day later, and magnitude 5.8, magnitude 5.5 June 2020. Ridgecrest was a humbling experience, Stein said. I think anybody would have told you that, given how we mapped California, that any fault that can release a 7.1 magnitude would have been known, and this was not known. It was unknown that this would have happened. The 2019 earthquakes along Ridgecrest added stress along the Garlic Fault, according to information gleaned from satellite data, Stein said. And the Ridgecrest area, as it turns out, is no stranger to big earthquakes. Over the past 150 years, the Ridgecrest area, an area within 90 miles of the fault, has experienced 4 earthquakes that registered magnitude 7 or higher. The at least magnitude 7.6 earthquake that struck Owens Valley in 1872, the magnitude 7.3 in Kern County in 1952, the magnitude 7.3 that hit Landers in 1992, and the magnitude 7.1 that shook Hector in 1999. All of these earthquakes added stress to the Ridgecrest Fault, meaning that while they did not directly cause the 2019 Ridgecrest earthquakes, they likely promoted them, Stein explains. However, the area's big earthquakes don't happen like clockwork, so it's challenging to know when the next powerful one might hit. And so, Stein says, to forecast when the next massive earthquakes might strike, Stein and Toda developed a new forecasting method. To be clear, a forecast is not the same as a prediction, because it's impossible to predict earthquakes. Instead, forecasts look at probability, or the chance that an earthquake of a certain magnitude might happen in a given place at a time period. This machine learning model looked at how stress was transferred by earthquakes and used past earthquakes to test its accuracy. In fact, the model shows that in June 2020, Ridgecrest earthquakes fit into the forecast for the region. The model showed, in part because of the added stress from the recent Ridgecrest earthquakes, that the Garlic Fault has a 2.3% chance of producing a magnitude 7.7 earthquake in the next year, or a 1 in 43 probability. This chance is 100 times higher than the 0.023 chance given by the third California earthquake rupture forecast, a forecast that is put out by Southern California Earthquake Center and the California Geological Survey, then released in 2017. And this possible magnitude 7.7 or even magnitude 7.5 earthquake along the Garlic Fault, the model shows, could trigger a large earthquake along the Mojave section of the San Andreas Fault, Stein said. So what should Californians do? There's another way of looking at the 1.15% chance that the San Andreas Fault will rupture and trigger a big one, and it's this. There is a 98.85% chance that it will not happen. Even so, it's good that the public and public policy experts be aware of this chance, however small, Stein said. It could also serve as a gentle reminder that people living near the San Andreas Fault should retrofit their houses to make them earthquake ready, assemble earthquake preparedness kits, and buy earthquake insurance, Stein said. He said, if you're a homeowner and you've been on the fence about earthquake insurance because it's too expensive, keep in mind that your risk just went up by a factor of 3.5 to 5, Stein said. It doesn't appear that insurance companies are raising rates because of this study, so you're basically getting insurance at a colossal discount, he said. Other geophysicists pointed out that the new study's model does not account for the Earth's intricacies. For instance, the model does not incorporate the complexities of fluid interactions, which can change stresses on faults over time, nor does it factor in the different types of rocks in the region. Pablo Gonzalez, the geophysicist with the University of Liverpool in England, who was not part of the study, told National Geographic. Stein said that since the study came out in the journal Bulletin of Seismological Society of America, he's talked with a number of colleagues who pointed out issues with the model. Many of these issues are addressed in the study's supplementary data, he said, but even so, models can never completely mimic real-world situations. Stein said, I feel that what we are saying is speculative and it's uncertain, and we acknowledge that and we understand that, but the flip side of that coin is that the consequences of this are so important that we should try to estimate it, and this should start a discussion of what we should be putting in our models of earthquake occurrence. And this is by Laura Gagel on Live Science. Please leave your comments. Thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.